Hello friends, welcome to True Event Academy. In this particular lecture, we will discuss about the constraint motion. So let's begin. So what is given in the question? Let us solve question number 1. Okay. A heavy particle of weight W is attached to a fixed point by a light inextensible string. Okay. Let us consider this as a string. It describes a circle in the vertical plane. So let us consider what is given in the question is that a heavy particle of weight W. So the weight W is attached to this string. It is drawing a circle in the vertical plane. Okay. So what is given in the question is that tension in the string has value MW and NW when the particle is at highest and the lowest point. This is the lowest point. Okay. Here theta is equal to 0. And this is the highest point. Theta is equal to pi. So this is the highest point. Okay, so the highest point is this and lowest point is this. Okay, so tension will act away from the body. Okay, so let tension at lowest point is T1. Okay, so we have T1 is equal to Tu. Tension at theta is equal to 0. Okay, this is equal to tension at the lowest point is MW. And tension at higher, let us consider the tension at the highest point. Let tension at highest point is T2. So T2 is equal to tension at theta is equal to pi. This is equal to MW. Okay, so let us recall our discussion on the calculation of tension and the velocity at particular angle theta. Okay, so what we have seen in the previous set of lecture is that suppose the initial velocity given to the particle is u. Okay, so we have calculated the value of tension and the velocity when the angle described is theta. Okay, so what we have seen, so the tension at random theta from vertical is given by tension T is equal to mu square upon a minus mg 2 minus 3 cos theta. Okay, suppose the mass of this particle is m. Okay, and the final velocity कैसे निकालते हैं? V square is equal to u square minus 2ag 1 minus cos theta. Okay, so in this particular question weight is given, so we can write W is equal to mg. This means m is equal to W upon g. Let us replace this. The tension is equal to W u square upon a minus mg. Sorry, mg के जगह पर W आएगा ना. W 2 minus 3 cos theta. Okay, so let us put these values. Okay. Okay, so T1 is equal to NW is equal to theta is equal to 0. Let us put theta is equal to 0 in this particular expression. So W u square upon a minus W 2 minus 3 cos theta. 2 minus 3 is minus 1. So this value become minus 1. So this is plus W. Okay, now T2 is equal to MW is equal to, let us put theta is equal to pi in this particular expression. So this is W u square upon a minus W, and this is cos theta is equal to minus 1. This is 5W 5. Okay, so this is T2 is equal to MW is equal to W u square upon a minus 5W. Okay, this is equation 1, this is equation 2. So let us subtract this. So equation 1 minus equation 2, we have NW minus MW is equal to W plus 5W. This is 6W. So n minus m is equal to 6. So n is equal to m plus 6. Okay. So what was given in the question? When the particle is at highest envelopment mass, show that n is equal to m plus 6. Okay, is the expression given in the question. Okay, let us proceed for solving next question. Okay, what is given in the question is that question number 2. A heavy particle hangs from a fixed point by a string of length a. This is length a, and a heavy particle is hanged from here. It is projected horizontally with velocity v is equal to root under 2 plus root 3 ag. Okay, so that the string becomes slack. Let us calculate the value of theta, value of tension at a random theta. Okay, we have seen in case number 4, case number 3 in the previous set of lecture, where tension becomes 0 prior to the velocity becomes 0. So let us find the value of tension at a random theta. Okay, so let us find this. So tension is equal to this we have already derived in previous set of lectures, mu square upon a minus mg 2 minus 3 cos theta. Okay, what is given in the question? String becomes slack when the string becomes slack, tension is equal to 0, and initial velocity given in question is v is equal to 2 plus root 3 ag root under. Okay, so now we have initial velocity. Let us replace u with v. Okay, so we have 0. Let us, when the string becomes slack, tension is equal to 0. So let tension is 0 at theta. Okay, so here let us consider tension is 0. So let us put tension as 0. So 0 is equal to m upon a into v square. The v square is given by 2 plus root 3 ag. Okay, minus mg. 2 minus 3 cos 2. Okay, so we have to find the value of theta. Okay, so we have, this gets cancelled. So we have mg 2 plus root 3 minus mg 2 minus 3 cos theta. Okay, so this is equal to 0. So from here mg gets cancelled. So 2 plus root 3 minus 2 plus 3 cos theta is equal to 0. The 2 gets cancelled. So we have 3 cos theta is equal to minus root. So cos theta is equal to minus root 3 upon 3. So we have cos theta is equal to minus 1 upon root 3. Theta is equal to cos inverse minus 1 upon root. Okay, so this is the required theta where the tension becomes 0, that is it gets slacked. Okay, so is the angle at which tension becomes 0, that is string gets slacked. Okay, let us proceed further. What is given in question number 3? A particle inside and at the lowest point of a fixed smooth hollow sphere of a radius a is projected horizontally with velocity 7 upon 2 ag, so that it will leave the sphere at an height 3 by 2 a from the lowest point, and its subsequent path meets the sphere again at the point of projection. Okay, so what is given in the question is that this is a sphere. Okay, so particle is at the lowest point. Okay, so it is given a velocity 7 upon 2 ag root under. Okay, so that it will leave the sphere at a height 3 by 2 from the lowest point. Okay, so this distance is a upon, this distance is a. Okay, so this distance will be, let us consider this as a upon 2. Okay, so this whole distance is 3a upon 2. Okay, 3a upon 2. So this is a, this is a upon 2. This is a upon 2. Okay, so what we have to show that it will leave the sphere at the height 3 upon 2a. So from here the reaction R becomes 0. This is given in the question. It will leave the sphere. That means it will follow a parabolic path and meet the lowest point. This is the parabolic path. Parabolic path. Okay. And here R is equal to 0 because it will no longer continue with the in a circular fashion because R is equal to 0. Okay. So now normal reaction becomes 0. So it will leave the circular path. Okay. And it will rather follow the parabolic path. This I have discussed in the this I have discussed in case number 3 in last lecture. Okay. So let us solve this. How we can solve this? So let us find the what we have to show that it will leave the. So basically we have to show normal reaction. Normal reaction R is equal to 0 when particle is at height 3a by 2 from bottom. Okay. Let us find this value theta. Okay. So we have sine theta is equal to perpendicular upon hypotenuse. So a upon 2 upon a, this is equal to 1 by 2. Therefore, theta is equal to 30 degree. Okay, so this angle is 30 degree. So this whole angle will be 30 plus 90, so 120 degree. Okay, so this whole angle is 120 degree. So let us find the value of what we have to show. To show r is equal to 0 when theta is equal to 30 degree and initial velocity is given by. So let us write down the expression for r. R is equal to mu square upon a minus mg 2 minus 3 cos theta. Okay, so r is equal to 0 when theta is equal to 30 degree. Okay, so let us show this. The value of r is equal to mu square. So u की value क्या है? M upon a into u square. U square is 7 upon 2 ag minus mg. 2 minus 3 cos of 120 degree. Sorry. Okay, so let us find this m upon a. This a gets cancelled. So this is 7m upon 2g. 7n upon 2g minus mg. This is 120. Cos 120 is, how can write? Cos 120 is equal to cos of 180 minus 60 degree. Okay, this is minus cos 60 degree. This is minus 1 by 2. So 2 plus 3 by 2. Okay, r is equal to. Let us further simplify this. So we have r is equal to 7 mg upon 2 minus 2 mg minus 3 mg upon 2. Okay, so this is equal to 3 mg upon 2 minus 3 mg upon 2. R is equal to, this is equal to 0. This means R is equal to 0 when theta is equal to 120 degree. So when theta is 120 degree, this means this point is at an distance of 3a by 2 upon 3a by 2 from the bottommost point. Okay, so hence at theta is equal to 120 degree, that is at 3a by 2 from bottom, particle will leave the sphere. Okay, तो यहाँ से leave कर जाएगा because here r is equal to 0 and theta is equal to 120 degree means this whole distance is 3a upon 2 because theta is equal to 120 itself we have calculated based on the this distance. Okay, based on the 3a upon 2. Okay, so this particle will be at a distance of 3a upon 2 from the bottom, and at that particular distance it will leave the surface, okay, and follow the parabolic path. Okay, now we have to show that this particle meets the meet at the lowest point, that is at point of projection. Okay, so let us show this. Okay, let us solve part 2 of this question. Okay, so what we are having is that at a distance of 3a upon 2 from the lowest point, this particle is leaving the sphere, rather it is following the parabolic path. Okay, so this angle is 30 degree, this is 90 degree. Okay, so this distance is, how we have calculated that, this distance is a by 2 and this distance is a, so this distance is a by 2. So now this is 30, so from horizontal we have this 30 degree. Now the velocity at this particular point will be perpendicular to the radius. Okay, so this will be 60 degree. Now let us find the velocity v at an angle of 120 degree. The initial velocity is 7 upon 2 ag. Okay, so we have v square is equal to u square minus 2 ag 1 minus cos theta. So velocity square is equal to initial velocity 7 upon 2 ag minus 2 ag 1 minus cos of 120 degree. Okay, so this is equal to 7 ag upon 2 minus 2 ag 1 plus 1 upon 2. This is 3a upon 2. This is 7 ag upon 2 minus 2 ag into 3 upon 2. So this is equal to ag upon 2 v square. This is v is equal to root under ag upon 2. Okay, so this is the velocity. This is ag upon. Okay, so this will rather follow a parabolic path. Okay, so this will be a case of a projectile motion. Okay, so what we have to show is that from here the particle is leaving the surface, okay, and following a parabolic path, and the path of this parabola is like this. Okay, so it will meet the lowest point at this particular point. Okay, so what we have to show is that first we have to find the equation of trajectory. Equation of trajectory keeping v is equal to ag upon 2 root under and alpha is equal to 60 degree. Okay, so from here the alpha we are getting as 60 degree. Okay, so because this angle is 30, so this angle will also be 30 and this whole angle is 90 degree. Okay, so this angle will be 60 degree. So v is ag upon 2, alpha is 60 degree and velocity is ag upon 2, root under ag upon 2. So what will be the coordinate? So let us consider this direction as positive. Okay, so what will be the coordinate of this? This coordinate will be this whole distance. This whole distance is a cos 30 degree. Okay, a cos 30 is a root 3 upon 2. And what will be the y? Value of y is minus, this is a by 2 and this is a. So this is 3 minus 3a upon. Okay, this is the bottommost point. Okay, let us find the equation of trajectory. Equation of trajectory क्या हो जाएगा? Y is equal to x tan 60 degree minus gx square upon to u square. U square is ag upon 2. U square cos square 60 degree. Okay. So y is equal to x root 3 minus gx square upon ag cos 60 degree. So cos 60 is 1 by 2. This is 1 upon 4 into 4. Okay, so this is y is equal to x root 3 minus 4x square upon a. Okay, this is the value of y. Okay, so this particular coordinate must satisfy this equation of um, trajectory. Okay, so when we put x is equal to this value a root 3 upon 2, we must get y is equal to 3a upon 2. Okay, so let us satisfy this. Okay, let us put x is equal to a root 3 upon 2 in equation of trajectory. Okay, so y is equal to a root 3 upon 2 into root 3 minus 4 upon a into x square. This is a square into 3 upon 4. Okay, so we have 3a upon 2 minus 3a. This is equal to minus 3a upon 2. Y is equal to. Okay, so when we put x is equal to a root 3 upon 2, we get y is equal to minus a 3a upon 2. This means this coordinate is satisfying the equation of trajectory. This means this particle will reach the bottommost point while traversing this path of the trajectory. Okay, this path, that is, by following this path, this particle will reach at the lowest point. Okay, so this is being asked in the question. This is given in the question. It will leave the sphere at a height 3a upon 2 above the lowest point, and at its subsequent path meets the sphere again at the point of projection. Okay, so this is obvious that this point a root 3 upon 2 minus 3 upon 2 is satisfying the equation of trajectory, because when we put x is equal to a root 3 upon 2, we get y is equal to minus 3 upon 2. Okay, so let us proceed for solving another question. What is given in the question? Find the velocity with which the particle must be projected along the interior of a smooth hoop of radius a from the lowest point in order that it may leave the hoop at an angular distance of 30 from the vertical. So what is given in the question? This is our hoop. Okay, so at an angle of 30 degree from the vertical, and this is this whole angle will be, so this angle will with the horizontal is 60 degree, this angle is 90 degree, so this whole angle is 150 degree. Okay, so at an angle of 150 from the bottom, this particle will leave the hoop. Okay, so at this particular angle, that is 150 degree, r is equal to 0. R is equal to 0. So we have r is equal to, let us consider the initial velocity is u. So we have r at an angle theta. R at angle theta is given by mu square upon a minus mg 2 minus 3 cos theta. Okay. So at theta is equal to 150 degree, r is equal to 0. So फिर 0 is equal to m upon a into u square minus mg 2 minus 3 cos 150. Okay. So cos 150 is equal to cos of 180 minus 30. Okay. So this is minus cos 30 minus root 3 upon 2. So 0 is equal to mu square upon a minus mg 2 minus 3 into minus root 3 upon 2. So this is equal to 0 is equal to mu square upon a minus mg 2 plus, this is 4 plus 3 root 3 upon 2. Okay, so this is equal to 0. So we have mu square upon a is equal to mg 4 plus 3 root 3 upon 2. Okay, so m gets cancelled. So we have u square is equal to ag upon 2, 4 plus 3 root 3. Okay, so u is equal to ag upon 2. Sorry. So we have, from here, let us take the square root. So we have under root. Okay, so this is the initial velocity. This initial velocity is ag upon 2 4 plus 3. Okay, so if you project the particle is with this initial speed, it will loop the hoop when theta is equal to 150 degree. Okay, so r is the normal component here. Okay, so the normal at the this particular point will be 0 when theta is equal to 150 degree. Okay, so based on these calculations, we have derived the initial velocity. What is given in further in the question, show that it will strike the hoop again at an extremity of horizontal diameter. So this will strike at the horizontal diameter. Okay, so what will be the coordinate? Let us find this velocity. Okay, so this velocity will be we derived from the expression v square is equal to u square minus 2ag 1 minus cos theta. So this value will be, this is a, so this will be a cos 60. This is a by 2 and this is a. So this is 3a upon 2 and this will be a, this is 30, this is 30, so a cos 30. A cos 30 is a cos 30, so a root 3 upon 2. This is minus a root 3 upon 2. Okay, so value of velocity at angle of 150 degree is v square is equal to u square minus 2ag 1 minus cos 150 degree. So v square is equal to u square is ag upon 2 4 plus 3 root 3 minus 2ag 1 cos 50 का वैल्यू क्या होगा cos of 180 minus 30 cos minus 30 1 plus root 3 upon 2. Okay, so this will be equal to ag upon 2 4 plus 3 root 3 minus ag 2 plus root 3. So this is equal to 2ag plus 3ag upon 2 root 3. Okay, minus 2ag minus 2 minus root 3ag. Okay, so this gets cancelled. So this is equal to ag common and root 3 common. So root 3ag which gets common. So 3 by 2 minus 1. So this is equal to 1 by 2. So root 3 by 2 ag. This is the velocity. V square. V square is equal to root 3 by 2 ag. So what will be the velocity? The velocity is equal to root 3 upon 2 ag ka half. V is equal to root under root 3 by 2 ag. Okay, so now it will follow a parabolic path. Okay, so what will be our, so this is like this. Okay. This is 60 and this is 30. This is 60, this is 60. This whole angle will be 30 degree. Okay, so what will be the equation for trajectory? Okay, so from here, this point, it will follow path like this and it will hit the horizontal diameter in the opposite side. Okay, so this is V is equal to this one and alpha is equal to 30 degree. The equation of trajectory y is equal to x tan 30 minus gx square upon 2u square. 2u square is this. So 2 root 3 upon 2 ag. 2u square cos square 30 degree. Cos square 30 is 3 upon 4. Cos square 30 degree. So 3 upon 4. Okay. Gx square upon 2u square cos square 30 degree. So y is equal to x upon root 3 minus 4x square upon 3 root 3. 4x square upon 3 root 3a. Okay. So now let us put the coordinate here. This coordinate must satisfy this equation of trajectory. So let us show this. So let us put x is equal to 3a upon 2 in equation of trajectory. Okay, so we have y is equal to 1 upon root 3 into 3a upon 2 minus 4 upon 3 root 3a into x square, 9a square upon 4. So we have this as root 3a upon 2 minus, this is 3, this gets cancelled to root 3a. Okay, so y is equal to minus root 3a upon 2. This is same as the y coordinate. This means this coordinate is satisfying the equation of trajectory. This means the particle will hit at the horizontal diameter from at an angle of 30 degree from the horizon, from the vertical. From here, the particle will leave the surface of the hoop and will hit at the horizontal diameter at this particular point, because the coordinate here is 3a upon 2 and minus a root 3 upon 2, and this coordinate is satisfying the equation of trajectory. Okay, so we will discuss further questions in the next particular lecture. Okay, thank you.